morning, good afternoon, good evening. My name is Jen Guile. I'm with NGINX Product Marketing, and I'm here to kick off the final live stream for our Microservices March Kubernetes Networking series. And here with me today, again, back on the NGINX webinar stage is Andrea from Learnk8s. Hey.
Hello. Welcome, everyone.
How are things over in Italy?
Not Italy, Amsterdam.
Oh, you're in Amsterdam.
Yeah, but it's all good. It's all good. Yeah, no, here it's great. We had a super nice couple of very sunny days. Enjoyed the nice weather outside, which is unlikely for Amsterdam.
I was going to say, I'm in the Seattle area. I think our weather is very similar. So today, Andrea is going to be talking about advanced Kubernetes deployment strategies, which is going to include looking at Canary deployments, blue-green, etc. We have our little canary here on the screen, and we'll be demoing how that looks using NGINX Service Mesh. So if you take a look at the video description, you'll see links to the companion blogs. We have one with a collection of resources that will dive deeper into these topics, and then another includes the lab guide that Andrea will be demoing today. If you're new to Microservices March, this is the fourth in the series. All of these live streams are available through our YouTube channel, so you can catch up at any time. And if you are participating in the full program, make sure you check out the technical reading and videos, again, linked in the description. And you can actually do the lab that Andrea is showing today in our browser-based environment if you register through nginx.com/mm. And we hope you'll join us on Slack to talk about these topics. So with that said, Andrea, take it away.
Hey, hello, everyone. And yeah, again, welcome from my side to this last episode of Microservice March, of NGINX Microservice March. Very happy to be here to talk to you about traffic shaping. So over the past couple of weeks, every Monday, we've touched on a different topic. We started talking about generic and, talking about what Kubernetes is, what an Ingress controller is. We approached then API, now we approach security. And today I'm here to talk about traffic shaping and how NGINX Service Mesh in particular can help us make our deployment better and help us to shape the traffic flowing inside our cluster using NGINX Service Mesh. Couple of words about myself. Hello, everyone. My name is Andrea Giardini. I'm an instructor at Learnk8s, and I'm a freelance cloud and infrastructure engineer. You can follow me on Twitter at Giardini Andrea. I publish some content related to Kubernetes and as well on the Learnk8s blog. So make sure you follow us on our social account. Make sure also to follow NGINX social accounts at nginx.com/mm for Microservice March. As Jen just mentioned, even if you didn't manage to attend some of the previous webinars, that's absolutely no problem. All of them are recorded and available on YouTube, LinkedIn, Twitter, and so on. So let's get started. When I do this kind of workshops and this kind of webinar, I always like to start with the easiest way possible. Very often you see tutorials starting with a cluster. These are ready, formed and so on. I always like to start with an empty Kubernetes cluster, which is the one that you see right now in the slide. So we have just a Kubernetes cluster, completely empty. And this also what represents is the fact that you will be able to apply what you will see today, not only on your local machine using Minikube or other tools like that, but on any kind of Kubernetes clusters out there. So if you're running on AWS, on Google Cloud, on Azure, or your own on-prem infrastructure, these guides still apply. Let's imagine that we have our Kubernetes cluster, which at the current status is empty, and we start, of course, by deploying a couple of applications. In this case, we decided to create two separate deployments, for example. One of them is a front-end deployment, and another one is an API deployment. You can just think about them like the usual, front-end, back-end architecture. As you can see from the slide, our front-end deployment, in this case, has a single replica. So there is a single pod that is taking care of our front-end component, while the API deployment, in this case, is made by two different replicas. So you can see that we have two pods in here. Both of them have the yellow color, and the traffic is routed from the front end to the back end in sort of like 50-50%, right? So 50% of the traffic is going to replica number one, and 50% of the traffic is going to replica number two. In this case, what we want to see in the next slides and so on is how we transition traffic from a first version of the API to a second version of the API. So just to make it more specific, what I wanted to point out with this slide is that this API is API version 1. So it's the first version of our backend, and currently, as we're mentioning, is receiving 100% of the traffic, 50% on the replica number 1 and 50% on the replica number 2. Now, let's take the next step. Our development team, after some weeks of working, is ready to finally deploy version number 2 inside our cluster. And so the next thing that we need to do is create a new deployment for version number 2, right? In here, I've simplified a little bit the slide. You can see that we still have our pod for the front end. We still have on the left side the 2 replicas of API version 1, still receiving 100% of the traffic. But on the right side of my slide, I created a single replica of API version 2. But as you can see, I haven't yet connected the frontend with API version 2. This means that at this moment, the frontend is still routing 100% of the traffic to API version 1, to the 2 replicas of API version 1. API version 2 is not connected. As you can see, there is no arrow between the frontend and API version 2, so it's receiving 0% of the traffic. Well, what's the next step? The next step is to connect this additional replica of version number 2 and allow it to receive traffic from the frontend. How can we do that? Well, in this case, what we would like to do is not to forward all the traffic to version number 2, but rather to switch gradually. So we would like for version number 2 to gradually receive more traffic over time. So one idea could be to group all these replicas that we have, the one of version 1 and version 2, behind the same service. If I do that, something like this happens. So API version 1 and API version 2 are 2 different deployments that share a common label. And the service that I created now forwards traffic to both of them, meaning that since the traffic is routed in a probabilistic way, that roughly 33% of the traffic will be routed to API version number 2, because there is a single replica, and 66% of the traffic will be routed to API version 1. So at this point, I made like a 66 to 33% traffic split, and 2 requests out of 3 are going to API version 1, while API version 2 is taking care of 1 request out of 3. Now, as I see that API version 2 is handling the traffic correctly, it is behaving the way I want, that there is no alarm triggered, all my monitoring signals and so on are going well, what I can do next is to increase the number of replicas of API version 2, right? I want to route more traffic to it. By having an equal amount of replicas between API version 1 and API version 2, in this case, 2 replicas for version 1 and 2 replicas for version 2, what I get out of this is a 50-50% split. So a request that comes from the frontend to the backend has equal possibility to end up on the version number 1 or version number 2 of the API. So I've increased the traffic going to version number 2. So right now the traffic is split 50-50. What would be the next step? Well, if I want to move one step forward, the next thing I can do is to remove one pod of API version 1. In this case, I have the opposite thing that I used to have a couple of slides ago, where API version 1 is now receiving a third of the traffic, while API version 2 is receiving 66% of the traffic. And finally, once I'm fully confident that API version 2 is working correctly, all my monitoring signals and so on are working, and they're showing me the right metrics, I can finally get rid of the deployment of API version 1, and now API version 2 is up and running, is working correctly, and it's receiving 100% of the traffic from the front end to the backend. So we sort of fixed the problem, right? What we wanted to do is do some traffic shaping, and we fixed it by playing with the number of replicas, right? So by influencing the number of the replicas of deployment 1 and deployment 2, we basically managed to do some traffic shaping, meaning that we could route at the beginning 33% to 66% or 50-50. Of course, by playing with the number of replicas, I can also reach like percentages that are much smaller. For example, I could deploy 9 replicas of version 1 and 1 replicas of version 2 to get a 90% to 10% split. But the question is this the best solution? Is this the best way of doing this thing? Does it make sense to spend so much time playing with replicas of different deployment just to achieve something so simple? What if there is a better solution? What there is a way of defining traffic rather than with the number of replicas as a percentage? What if I want to, try to draw something like this? What if I want to have something like, well, I have one replica of version 1, I have one replica of version 2, and I just want to route 80% of the traffic to API version 1 and 20% of the traffic to API version 2. If I would want to do that just with replicas, what I would have to do is to create 4 replicas of version 1 and 1 replica of version 2 to obtain this split, right? And they might actually not be needed because maybe my frontend is not sending that much traffic. Is there a way that I can achieve this by using different tooling? How can we do that? Well, this is what we will see NGINX Service Mesh is for. NGINX Service Mesh allows us to route traffic inside the cluster with a specific percentage and weights. How does it work? We will see it in detail during the demo. But the idea is that when we are using NGINX Service Mesh, the Service Mesh attaches an NGINX proxy to each pod that is part of our cluster. This container that is added to every pod is called a sidecar proxy, meaning that all the traffic that is outgoing and incoming from our pod and to our pod will be forwarded through the NGINX proxy. And by using this proxy, we can do some smarter traffic shaping inside our cluster. How can we do that? We will see that in the demo as well. It's using CRDs. CRDs are the customer source definition. If you've been using Kubernetes for a while, you probably know what they are. They're basically resources that are custom to Kubernetes, that they're not included in the vanilla Kubernetes distribution, but that they can be installed. In this case, they will be installed by the NGINX Service Mesh. The idea is that I can create a customer source definition like this one of kind traffic split, as you can see in the second line. And then in the lower part of the definition, this is a YAML file like any other Kubernetes resource, I can define how I want my traffic to be split. So in this case, what I'm saying is that for the service backend-svc, I want the traffic to be routed 80% to backend version 1 and 20% to backend version 2. And you can see, since I'm managing this as a Kubernetes resource, it means that I can include it easily inside my Helm chart. I can include it easily into my GitOps repository and so on. And change also the traffic inside my cluster as a code as well. What we get out of this is that by changing the traffic split resource, we're basically shifting traffic from one backend to the other. And remember that we're doing this now without doing any kind of creating new replicas, removing replicas, and so on. Everything is happening just inside the traffic split CRDs. Let's have a look at it, and let's see how we can do that using the power of NGINX Service Mesh. Okay, so here you have on the right the page of the GitHub project of NGINX Service Mesh. You can find it under the NGINX Inc. organization. And on the left side, here you have my terminal. So the first thing that I'm going to do is, of course, starting Minikube. We will have to start with a couple of different parameters. These are needed in order for NGINX to work correctly, but you can find all those parameters in the NGINX blog. So over there, you have all this tutorial. You can follow them by yourself on your laptop. You can try them out on your cloud deployment. That's absolutely no problem. But remember that when you start Minikube and you want to use NGINX Service Mesh, you will have to do that. You will have to add this couple of different extra configuration flags. So up here, these 4. Okay, good. So Minikube is now up and running. I am just going to clear the screen, do kubectl get pod dash uppercase A. This will print all the pods inside my cluster. As you can see, it's a brand new cluster. There is nothing more than the core components of Kubernetes, right? So in this case, the next step is obviously installing NGINX service mesh. I'm going to do that with this command over here, and no worries. It's not that long, it's very easy. I'm actually using Helm to install the NGINX service mesh inside my cluster. Helm, in case you're not familiar with it, is like a package manager for Kubernetes, basically. It allows you to install a set of resources inside your Kubernetes cluster just with a single command. So in this case, I'm just installing NSM is NGINX service mesh. I'm installing it from the official NGINX repository. I'm installing it into a namespace called NGINX-mesh. I'm asking also Helm to create this namespace for me, and here I'm adding an extra value to this Helm chart. Let me show you that value. I wanted to keep it on a side just because, yeah, you will see it in a second. So this one is a value that I needed to change, in particular for this demo. This is not a setting that I would recommend for production use, of course. And the idea is that when you use NGINX service mesh inside your cluster, NGINX service mesh is going to keep track of every request that is made inside your cluster. Usually, you don't want to do that, meaning that you don't want to trace all the requests that are going on in your cluster, because that's a lot of workload. But usually what you want to do is trace a percentage of them, 10%, 20%, 30%. It's up to you, really. Of course, if you're trying to trace 90% of the requests, this may introduce a lot of additional load. In here, what I'm asking NGINX service mesh to do is to trace all the requests. This is a number that goes from 0 to 1, where 0 is 0% and 1 is 100%. As I said, I don't recommend this for production, but for demo purposes, this is just much easier to show quickly the changes that I'm doing. So this is why I need this extra line when I'm running Helm. So let me copy the command again. Here we go. I press enter. And now what will happen is that NGINX service mesh will be installed in the cluster with the demo values that I just shown you in a new namespace called NGINX-mesh. This might take a couple of minutes, so this is nothing to worry about. There are several components in particular that need to be created in order and running in order for NGINX to be functioning correctly. So let's have a look at them quickly. I'm clearing the screen. Again, kubectl get pod-a, all the pods I'm printing right now. Here we go. As you can see, there are many more containers that are created. Let me actually select only for the namespace NGINX mesh. In this way, we can see all the pods that are part of NGINX mesh namespace only. So as you can see, different pods have been created. In particular, 7 different pods have been created. We have NGINX mesh API and metrics, which are core components, as you can imagine, to the NGINX mesh. But also, there are a couple of external components that we can talk about. There is a monitoring agent, Prometheus. Some of you might be familiar with the Prometheus monitoring system, together with a Grafana dashboard. This will allow us to see some statistics about NGINX mesh, number of requests that are going on, health status, and so on. Then you see down here that there is a NAT server. NAT server, if you're familiar with it, is nothing more than a message broker. So it's basically a tool that NGINX service mesh uses to send and receive messages in between different components. There is a Spire agent. This is our certificate authority. Basically, what NGINX service mesh provides out of the box is also MTLS encryption between different pods. What the Spire agent and the Spire server do is making sure that all these pods have a certificate and that they can communicate in a secure way, basically. And finally, Jaeger. We will see the interface of Jaeger later during the demo. This is a web interface that basically allows us to see how the traffic flows inside our cluster. So we gave it a couple of more minutes. Let's see if now, perfect. All the services are up and running. It looks like NGINX service mesh was installed correctly inside our cluster. Now, what's the next step that we need to take? Well, we want to start deploying some applications, right? And see how the traffic flows in between them. So in order to do that, I prepared a couple of examples here. So the first example is a backend service. It is a very easy backend service. I will try to sort of like remake the infrastructure that you have seen already in the slides, but the idea is that in here, you have a backend version 1 deployment. This deployment has two labels, app equal to backend and version equal to 1. And it's a very easy and boring deployment, basically. It's just an NGINX server with a very simple configuration. And what this configuration does is always return HTTP code 200 and a small JSON saying name equal backend, version equal 1. So it's a very straightforward deployment. So we're deploying a configuration map. This is the nginx.conf configuration. Then down here, you can find the resource, the deployment manifest, backend version 1 with two labels. Keep these in mind, they're really important. So app equal to backend and version equal to 1. And finally, a service. So our service, as you can see here, something that I would like you to notice, let me zoom in a little bit more, is that this service name is backend-svc. It's receiving traffic on port 80 and forwarding traffic on port 80. And the selector for this service is just app equal to backend. So remember that this deployment has two labels, app equal backend, version equal 1, while this service has a single selector, which is app equal to backend. We will see later why this will come useful. So let's save this. And now what I'm going to do is to clear the screen and do kubectl apply-f demo backend version 1.yaml. Press enter. As we can see, config map, deployment, and service have now been created. Let's have a look at them and make sure that everything is healthy. Get pods in the default namespace. Default. Okay, here we go. We have our pod up running. This looks nice, but if you pay attention to what I've shown you before, in part of the deployment part, you should see something suspicious in here. What we have done before is create a deployment with a single container inside. But what do we see here? We actually see that Kubernetes is telling us that our pod, backend version 1, does not have a single container, but has two containers. That sounds strange, maybe, but we can have a look at this container, this pod, sorry. Describe pod, and see what the other container is doing. Backend. Okay, perfect. This will be very verbose. But if we scroll up a little bit, we see there is an init container, which is from NGINX service mesh. And what we can see in here is that now we have two containers. The first container is our backend version 1, which is the container that we defined in our deployment.yaml file. The second container is called nginx-mesh-sidecar. This is the sidecar container we were talking about previously. So this is the sidecar container that nginx service mesh is going to inject in every pod that we create inside our cluster. So currently, we have one pod running with two containers inside. One container is running our workload, backend version 1, and the other container is running the nginx mesh proxy, which is also called like a sidecar proxy. Basically, all the traffic that we're going to send to this pod is going to will go through the nginx service mesh sidecar before reaching our application. And in this way, nginx service mesh can keep track of all the traffic incoming and outgoing from our application. And as we will see later, trace it in a nice way. Let's move to the next step. Perfect. So now we deploy the backend. As we've seen how we've done it. Now it's time to deploy the front end, right? The front end is even easier than the backend. So the front end is a very small application. It's just a deployment with name equal to front end. It has a single label, app equal to front end, and it's basically just running curl. So as you can see here, this is basically doing looping over curl, and every 1 second, you see here, sleep 1 second, it will curl our backend service. So every 1 second, this frontend will call the backend service and show us the result. Let's deploy it as well. kubectl apply -f demo frontend. Okay, even in this case, it was created. If we do kubectl get pod-a, we should see the whole list. So in here, you can see very easily. Down here, we have the pods of NGINX Service Mesh. We talked about them before. In here, you have the kube system pod that are needed for Kubernetes to work correctly. And up here, we have our backend version 1 and frontend running inside the cluster. As you can see, even in the frontend, we have the NGINX Service Mesh sidecar container. So automatically, NGINX Service Mesh adds this extra container to all the pods inside the cluster. We will see later during the slides how this actually happens. Next, we can have a look definitely at the logs of the pod. So at this point, our frontend should have started making a request to the backend. So I can do kubectl logs frontend. Well, of course, since right now my deployment has more than one container inside, kubectl is asking me, well, of which container would you like to see the logs? In this case, I want to see the logs of my application. So I will specify -c frontend. And here we go. As you can see here, of course, we have deployed just the frontend and the backend version 1. So the logs of, I can also follow them, but basically every couple of seconds, my frontend is pinging the backend. And the only backend that I've deployed is backend version 1. So of course, it's always returning name backend version 1. Now, let's have a look at the NGINX Service Mesh. And what do we get with such a, we created just a simple front end and backend. They are talking with each other. Let's see how NGINX Service Mesh represents that into a graphical way. In particular, we will have a look at Jaeger. So before opening the interface, the web interface, I need to run this command. This basically makes the Jaeger service of type node port. In this way, I can access it easily using Minikube. This is, of course, something that maybe you should not do depending on your configuration, but maybe it's not a good advice to do it in production. But then the next thing that I'm going to do is do Minikube service Jaeger -n NGINX -mesh. In particular, I had to do this kubectl patch here and changing the service to spec type node port so that I can now access it using Minikube. Otherwise, I would have to play with kubectl port forward and things like that. Of course, depending on your cluster configuration, but type node port gives access to that particular service to anyone that also has access to, that can reach that particular node and that particular port. So you might want to keep it of type cluster IP if you're running it in a cloud environment, for example. By running Minikube service Jaeger, what is going to happen is that a couple of browser tabs are going to be open on my browser here. These two are not needed, but here we go. I have my Jaeger UI here, and I can explore the data that is provided to me by the Ingress by the NGINX Service Mesh. So the first thing that calls your guard is that in here, first of all, we have two services. And here we look what we found. Frontend NGINX, backend version 1 NGINX. So let's have a look, for example, at the frontend NGINX. I'm limiting the result to the last 20 traces. So if I click find traces now, what I will get is the performance and the request that were made in the last 20 seconds, basically, because remember, the frontend makes a request every single second. So each one of these dots is a request that my frontend made to the backend. You can see that in here, they go between 1 millisecond and 2 milliseconds of duration. So in here on the y-axis, you have the duration of the request, and on the x-axis, you have the time. And down here, you can have a look at all these requests. In particular, a couple of things are interesting in here. First of all, you can see the involved parties. So in here, you can see that frontend NGINX and backend version 1 NGINX have been involved in this request. You can see at what time it happened, in this case, a few seconds ago, and how long it lasted. So in this case, 1.34 milliseconds. If you click on it, You can even see the details of how long the request took, how much time was spent in the front end, how much time was spent in the back end, and so on. So this is a very detailed view of your request. In our case, it's just a simple call. It's very simple, but you have to imagine handling this when you're running in in a distributed microservice environment where you might have a lot of interactions, maybe some interaction you're not even aware of, right? Another tab that I would like to show you here is the System Architecture tab. System Architecture tab is very nice because it shows you in a graph how the interactions are going on inside your cluster. In this case, you can see clearly that the Frontend NGINX is the one calling our backend version 1 NGINX. The number of that in here is not a percentage. This is something that confused me as well, but it's just the number of requests that have been registered by until now. And this is why before, when we installed it, when we installed the NGINX Service Mesh, and I told you to set this sample rate to 100%, this is what I meant with that. Right now, what I'm asking NGINX Service Mesh to do is to trace every single request going through my system. And this, if you have like hundreds of thousands of requests or things like that, can be very dangerous because it can easily overload your own cluster. Also because this is something funny that I noticed yesterday. Now, as you can see, the number of service increased from 2 to 3. So before I had the front-end and back-end service. Now there is something else. And well, this is basically the Jaeger query that I make every time I click on this. So every time I click this, of course, I'm making an HTTP request, right? So every time I click a button on this interface, also this query is traced by Jaeger because it's still part of the service mesh, right? All this is running inside Kubernetes. All this is running as pods inside Kubernetes. So also these requests are traced, which is which is impressive. I found it funny yesterday when I saw the number 3 here, and I was like, well, strange. Perfect. So right now, our use case was very simple, very straightforward. Let's now move and make the example a little bit more complicated, okay? Well, the first thing I'm going to do is to deploy a second version of my application. So right now, what I want to do is to deploy version 2 of my backend, and then we will see what happens. So I have it already here. It's ready to be deployed on this file. Let me show it to you quickly. This is almost identical to backend version 1. There are just a couple of differences. The first difference is, of course, that in this case, I'm returning HTTP code 200, and the JSON says name equal to backend, version equal to 2. And of course, my deployment is now named backend version 2, single replicas. It has 2 labels, app equal to backend, version equal to 2. In this case, I'm not creating any service here. Remember that the backend-svc service is routing traffic to all the pods that have the label app equal to backend. So as I apply this configuration, and as this deployment becomes ready, my service will start forwarding traffic to backend version 1 and backend version 2 at the same time. So let's deploy it, and let's see what happens. So kubectl apply -f demo backend version 2. Perfect. Clear the screen. kubectl get pod -a. And we see up here that now we have the version 1 of the backend that is running. Down here we have version 2, and finally our frontend. And since backend version 1 and backend version 2 are behind the same service, what I should see right now, if I do kubectl logs frontend -c frontend, is that my frontend is sending roughly 50% of the request to version 1 and 50% of the request to version 2. Both of them have 1 replicas. Services use a probabilistic way of forwarding resources to the pod that match their selector. So I would see that around 50% go to version 1 and 50% to version 2. So if I follow and press enter, here we go. You can see it in here, requests are flowing. And as you can see, you have version 1, version 2, version 1, version 2. They are basically, the requests are alternating between the version 1 of the backend and the version 2 of the backend. Let's see how does it look like in my Jaeger interface. So I'm just going to click Find Traces again. This gives me always the last 20 traces that have been collected. If I click Find Traces, some traces here are still incomplete. This is why you see this small dot. I can try to click it again just to see if maybe they're getting updated. Here we go. So by the time I clicked again, the trace was completed. So you can see this difference even on Jaeger, right? Because now you have some traces like this one, where the front-end NGINX and the backend version 2 NGINX are involved, and some traces like this one, where front-end NGINX and backend version 1 NGINX are involved. Now, this is a bit unlucky that we get like backend version 2 and front-end NGINX with two colors that are very similar. But yeah, you can see that in here, you have version 2 of the backend, version 1 of the backend, version 2, version 1. So yeah, as I was saying, roughly 50% of the requests go to version 1 and 50% of the requests go to version 2. You can see it clearly in here. Of course, this is also going to be represented in our system architecture. Let's have a look at it. Our DAG now shows clearly that our front-end deployment is sending requests to backend version 1 and backend version 2. The difference between these two numbers, as I was saying before, represented the number of traces that have been collected. So in our case, we spawned backend version 1 way before backend version 2. So as you can see, there are more traces collected for backend version 1 than for backend version 2, but that's perfectly normal. The idea is always that right now we are collecting all the traces that are running inside our system, but obviously, in case you are running on a production system, you don't want to trace all the requests going through your cluster. You might want to trace, just a certain percentage, maybe, especially if you have clusters that are running like a high, where you have like many requests and so on. Perfect. Now, in the next stage, what are we going to do? So let me split this terminal here and go down here. So this is the same shell, the same repository that you will also find on the NGINX blog, in their guideline, in their tutorials, and so on. So now we want to use the traffic split CRD to split the traffic between version 1 and 2 without having to touch the number of replicas that are running inside our system. So we want to decide how much traffic is going to version 1 and how much traffic is going to version 2 without having to scale up and down our deployments, right? This was the point of the whole demo. So let's have a look at the resources that we need to create and how we can configure them. So the first resource that we need to create are a couple of extra services. Why is that needed? Well, we created backend-svc. That's a service that routes traffic to both our deployment. Now I want to create two services that instead are specific. So I'm creating a service called backend-1. Let me remove this top part for now. We will get back to it later. I want to create a service called backend-version1. And as you can see, this service is routing traffic exclusively to my backend version 1 deployment. And then I'm creating a second service called backend version 2. In this case, I'm asking this service to route traffic exclusively to the pods that are part of the deployment of backend version 2. Let's go on and create these two services. kubectl my-f demo services. Here we go. Two services are created. I can even list them. kubectl, let me clear the screen. kubectl get service and default. Here we go. I have the default Kubernetes service that you find in every namespace, and then I have three different services: backend-svc that I created right at the beginning, and then backend version 1 and backend version 2. Now, the last component that we need in order to do traffic shaping using NGINX service mesh is a CRD called traffic split. Let's have a look at it. We've seen it in the slide, but I want to show you what I'm applying to our cluster. So in this case, we have a CRD of kind traffic split. Remember that this CRD is not available out of the box inside your Kubernetes cluster. This is something that is provided by NGINX Service Mesh. So you will have to install NGINX Service Mesh before applying this manifest. The name of this traffic split is called backend-TS, which stands for traffic split. And then what I'm saying in here is, well, the service backend-SVC should route traffic in the way specified below. So let's imagine that I'm actually in a production environment, okay? I want to route 100% of the traffic to version 1, which is the version that they consider safe, that it works, and 0% of the traffic to backend version 2. So what I can do now is save this manifest. I'm going to show you again down here the logs of the application. As you can see here, the logs of my frontend are still flowing. Now I apply kubectl apply dash f demo 5 split.yaml. Have a look. Right now, our requests are 50-50%. So 50% going to version 1, 50% going to version 2. Remember that our frontend is targeting backend-SVC, which is just a normal Kubernetes service for now, routing traffic 50% to version 1 and 50% to version 2. Let's see what happens as soon as I apply traffic split. I apply this traffic split. We put a couple of spaces and have a look. Down here, what happens right now is that I'm only eating backend version 1. So my frontend now is still targeting the same service, but our NGINX service mesh is now forwarding traffic only to version 1. And that's because inside my traffic split that I defined here, I clearly specify that I want backend version 1 to receive 100% of the traffic and backend version 2 to receive 0% of the traffic. So the traffic right now is split in this way. Let's try to play with these numbers and see what happens. So the next thing I'm going to do is forward 75% of the traffic to backend version 1 and 25% to backend version 2. So roughly, I should see 3 requests going to version 1 and 1 request going to version 2. Let me save this file. I will apply it again. Add a couple of spaces in here. So we see still request going to version 1. And here we go. Some requests are also going to version 2, as you can see. Of course, you don't have to think it in a way that exactly I will always have a 3 requests to version 1 and 1 to version 2. But it's roughly, I mean, the idea is that when you have like a lot of requests coming in, 75% will go to version 1 and 25% to version 2. But you might even have 2 requests, one after the other, both going to version number 2. But you can see in here that now traffic is routed both to version 1 and version 2. And you can still see that version 1 is getting the majority of the traffic here. I can, of course, just go back to the usual way services work and say, well, I want now the split to be 50-50. So 1 request for version 1 and 1 request for version 2. And when I apply it, you should see that directly in my logs. So the idea is that now we get a 50-50% split. So the same amount of requests go to version 1 and the same amount of requests go to version 2. And finally, when I'm happy about my deployment, I see that version 2 is behaving in the right way and so on, I can finally change my traffic split to stop forwarding traffic to version number 1 and to forward 100% of the traffic to, 100% of the traffic to version number 2. So in this way, what I'm saying is I don't want traffic routed to version 1 anymore, just forward 100% of the traffic to version number 2. I will now save this traffic split. Of course, I will apply it. And down here now we should see that 100% of the traffic is flowing to version number 2. You can see that every time our frontend is showing backend version 2. So we always get the same answer, and the answer always comes for version number 2. During all this time, Jaeger in here has been tracing all our requests. So you can see that down here, we have a whole bunch of requests just to version 2. And this is just because I'm tracing the last 20 requests, right? So it's always interesting to see how this works. In here, of course, it's showing me that some requests before we're going to backend version 1. But yeah, Jaeger is a very nice way to have a look at traces, to see how long they last, to see which components are involved in a certain request, because sometimes it might not be obvious. Now, in an example like in this one, we have just a couple of a couple of different deployments that can interact with each other, but imagine this at scale, right? Perfect. So why you might want to use a service mesh, why is it useful, why you should use it, why you should not use it. So these are a couple of the advantages that you get with a service mesh. And this is also what we've seen today. The first advantage is definitely observability. And this comes in different shapes and forms: monitoring, tracing, fault injection. Of course, when you install a NGINX service mesh, as we've seen before, you also get out of the box Prometheus and Grafana, so you can use also that for monitoring. We haven't seen it during the demo, but it's pretty easy to use. We've seen tracing using Jaeger, so the possibility to analyze all the requests that are going on into your cluster and see which components are interacting with each other, if a certain component is slower than other, why certain requests do not perform as others do. And finally, these are something that we haven't touched during the demo, but it's quite interesting. You can also do things like fault injection. If some of you are already doing some practice like chaos engineering and so on, this might become really useful. This means that basically I can see, well, let's imagine that the communication between these two microservices doesn't work. And I can see how my system behaves when there is a fault inside my cluster. So I'm basically on purpose injecting faults inside my cluster to see how my application behaves. And if the application doesn't behave correctly or doesn't behave in the way I want, I can then make sure to fix that problem so that I don't find out about problems in production when everything doesn't work and I get paged at 4 a.m. in the morning. Then, traffic shaping. We've seen it clearly today. It's possible, in particular, using this custom resource definition called the traffic split to shape the traffic flowing in our cluster in a super easy way. So today we talked about Canary releases, but of course, in case you want to do something like shadow releases or traffic mirroring and so on, this is all possible using NGINX Service Mesh. And finally, like last but not least, security. Airbag policy, authentication, end-to-end encryption. We've seen this component called Stripe, no, something like that. Basically, acts as a certificate authority for our NGINX service mesh. So make sure that all the pods are communicating between them in a secure way using certificates that are created on purpose to let services and pods communicate with each other in a secure and encrypted way. But how does it work? We've seen it right in the beginning that whenever we created a new deployment, our container was automatically added to each one of our pods. Well, this takes care of a functionality inside Kubernetes, which is the mutation webhook or the mutation admission controller. Basically, what happens is that whenever you submit a new resource to a Kubernetes server using kubectl apply, for example, this request goes through different components inside your Kubernetes control plane. And one of these components is called the mutation webhook. What this component does is basically take your request and change it if it respects certain parameters. So what the NGINX service mesh is doing is basically taking all the requests that are going to pods, for example, and saying, well, for every pod that is created, inject an extra sidecar proxy that will allow NGINX service mesh to trace the traffic and monitor the traffic flow inside your cluster. We have seen this was also like a super nice thing of Jaeger, how it allows you to also see your system architecture. In this case, it was just an example for with a couple of microservices. Imagine this at scale when you have like hundreds of microservices. Sometimes it might be difficult to understand how these components are working together, which component is talking to which, and so yeah, even just having this part of the whole. I mean, using NGINX service mesh is nice from the point of view of tracing and so on, but of course, being able to see your system architecture in a graphical way, especially in a microservice environment where you might have hundreds of microservices talking to each other, it's even nicer. Of course, NGINX service mesh is not the only one out there. So here I put a couple of more service meshes out there. Istio, Linkerd, Kuma, Consul, they're all valid service meshes. But of course, I invite you to check out NGINX service mesh. They're super active in their Slack channel. And in case you want to have a look also to the other, to do some comparison or things like that, you can have a look at Learnk8s.io. This is our blog. We created a small comparison of the service meshes out there, the more popular one, by showing which feature they support, which feature they don't support, or they are planned basically. So make sure to check it out. I'm sure somebody is going to share it in the chat. Yeah, final thanks. Microservice March wouldn't be possible with the help of Daniele from Learnk8s and of course Jen, Marco, and Brian. So thank to all of you. But yeah, also thank to all of you for attending this webinar. It looks like we have a lot of people watching us on YouTube, on LinkedIn, Twitter, and so on. If you have any question, please write them in the chat. We will make sure to address them as soon as possible. I invite you to follow Microservice March, to join our Slack channel. And yeah, I hope you enjoyed this demo. I hope you enjoyed this content, and I hope to see you around, definitely.
All right, thank you. We have a lot of really great questions. We've got about 10 minutes left until the top of the hour. So let's start out with a what sounds like a very straightforward question, but you probably have heard it before. Two people asked this one, Young Bay and Cesar Valencia. Can you do this only with a service mesh, or could it also be done with an Ingress controller?
Unfortunately, a service mesh is needed in this case. So Kubernetes provides a set of base components like services. So services are a very effective way to forward traffic, but they don't allow you to do traffic shaping in the way service meshes do. And I understand that for some people, this might look like I don't know, installing service mesh still means that you need to have an additional container in every pod running inside your cluster. So some people might be worried about, okay, what happens with performance? Will I get, will my request get slower? What about the resource usage and so on? Well, my suggestion would be to give it a try. I mean, at the end, service mesh from NGINX, but also any other service mesh out there are very highly optimized. Meaning that, yeah, they will introduce some extra latency. They will introduce a bit more resource usage and so on. But especially if you're working in like complex system where you have like many different microservices out there, maybe it's something that you still want to do, like making sure that you can see where your requests are going, which components are talking with each other. But yeah, I believe out of the box, it's not really possible with Kubernetes.
Yeah, so we dropped a link in the chat that talks in more detail about traffic splitting in Kubernetes. So the demo that you showed, the backend services, definitely requiring a service mesh. If you're doing something where it's the front end and you wanted to split traffic between a front end V1 and a front end V2, you can do that with an Ingress controller, and so we've put that in the blog. So it really depends on the use case. But you just said something that leads into another question from Leonardo. He asked, can I use NGINX service mesh without a subscription? Yes, absolutely. It's completely free, as are most service meshes. However, you may have heard of a term, free like a puppy. So it may not require your money, but all meshes will require some amount of your time. So we'll drop a second blog link in the chat. Oops, there we go. Let me put it over here so we can get that in, on how we recommend deciding how to choose a mesh, if you're ready or not. And so Andrea, I'll pose the question to you. How do you help people understand whether or not they're going to get value from a service mesh?
Very good question. Very good question indeed. So first of all, one thing that I want to point out is before you go into the rabbit hole of choosing a service mesh and so on, I recommend having a certain experience with Kubernetes, first of all. Kubernetes networking, if you have followed a course about Kubernetes, you know that Kubernetes networking is already quite complex. Let's put it in this way. And a service mesh, not only NGINX service mesh, creates another networking layer on top of that. This means that when something goes wrong, things are even more difficult to debug. So the first recommendation that I would do is take some time to understand how Kubernetes how Kubernetes networking works. Have some experience with Kubernetes itself, and once you feel confident enough, start digging into the world of service meshes. Then, how do you choose between different service meshes? Well, depending on the cloud provider where you're running, you might have some of them as a managed service. That's definitely a good thing to evaluate. But also, I'm sure in the link that you posted, but also in our comparison on the Learnk8s blog, you can have a look at which features you need. Because some service meshes, for example, do not support UDP. That's just an example. Some service meshes support only certain type of authentication or authorization and so on. So it's more of a matter of finding out the one that checks all the points in your checklist. And then just giving it a try, basically, in a testing environment. I would recommend. So test it out in a testing environment to create
Don't put it straight in the prod.
Yeah, no, don't go straight in prod because you are going to get hurt. Let's put it this way. But yeah, and also think as well that service meshes are a relatively new topic also in the Kubernetes world. So there is a lot of work going on in all of them, basically. So they are growing. Their adoption is growing as well. But yeah, I mean, they all should be used with caution. Let's put it this way.
Yeah, I liked the slide that you showed a few minutes ago on the three overall, use cases for a service mesh: the observability, the traffic management, the security. And so in the blog that I dropped, in addition to kind of having like a little checklist of factors that indicate you might be ready for one, we also really advocate deeply understanding what you're going to use it for, and then picking a mesh based on why you're going to use it. Because on the other side, there are meshes that have like a million features, and that can also get you into trouble.
Totally. It's also a matter of okay, are you working for like a 10-person startup, or are you working for an international bank? Because those are like two completely different use cases that obviously require two completely different approaches in terms of security, in terms of observability, and so on, right?
And even just humans, some meshes require a person to maintain it, whereas NGINX Service Mesh doesn't. It's really easy to use, and so it kind of depends on how many people you can invest in it. Okay, so let's see here. We have a lot of questions. I don't think we'll get to all of them, but we'll do our best. So
it's a good opportunity to push our NGINX Slack channel in the chat. So we can follow up there in case we don't manage to get all the questions now.
Someone with the username My Videos wants to know, can we specify which apps will be subscribed to a service mesh, or is it applied cluster-wide by default?
That's a good question. I'm not 100% sure I have an answer for that, because for the demo, as you can see, by default, it's applied to every pod. So it will be basically injected into every single pod that you have inside the cluster. I will have to get back on you on that in particular. But it's a good question, because indeed you might also want to say, okay, I want certain applications to have service meshes and see, even just to give it a try and test it out, or I might want all of them to have it. Yeah, good question, but I will have to get back to you on that.
Yeah, and it might be a use case where if you really don't want an app managed by the mesh, then putting it in a different cluster could be the right choice.
Yeah, true, definitely.
Okay, let's see here. I thought we had some more. We have one from Brad. Brad asks, specifically back to Jaeger, since you made changes and then things were skewed since the V1 deployment was already running, Brad wants to know if there's any way in Jaeger to easily reset those stats so that they both start at a specific point in time.
I see. Well, you can definitely select, like I haven't showed it in the demo, but you can select the time range that you want Jaeger to analyze. So yeah, you can definitely do that in Jaeger. But as I was mentioning also during the demo, Right now, what I was doing was tracing every single request. So when you were showing the system architecture, you would see like a big gap between version 1 and version 2. Of course, if you're doing that in, if you're, instead of tracing 100% of the request, you trace 10% or 15 or 20% of the request. In that case, the difference is going to be much smaller and sometimes not even noticeable really at scale.
Okay, and then we'll take one final question and then we should wrap up. This person wants to know, is it possible for one service mesh deployment to manage the traffic of 2 load balancers? I am going to guess that they mean 2 ingress controllers, not 2 load balancers. So let's answer it from that point of view.
Well, as you've seen, the traffic, I mean, the traffic split acts on the service, right? So if you have ingresses that are routing to a service, then you're basically just playing with the service traffic split, as we've seen right now, and you can play with where the traffic is being routed. So my answer would be yes, because ingress controller, load balancer, and so on under the hood will still use Kubernetes services, and that's where NGINX service mesh acts.
Yeah, so if you think about north-south being ingress, egress, east-west being service to service, the service mesh hangs out at that service to service east-west layer.
Yeah, totally.
Okay, I think that's all we have time for. Andrea, I can't believe the month is over.
It's been fun.
Thank you, and thanks to everyone from Learnk8s. So this will be available on demand, as well as the other 3 webinars. And of course, check out the blogs that go with them if you want to try out the demos. With that said, thank you everyone for joining us for Microservices March. And thanks, Andrea.
Thank you very much. Goodbye, everyone.